Hello and welcome back to this channel. Dear students, this topic is magic T. This structure is also called hybrid T. It is combination of E plane T and H plane T. In the earlier video, we have studied uh, the structure and working of E plane as well as H plane T. So this is the diagram of magic T or hybrid T. As shown in this diagram, there are four ports: port 1, port 2, port 3 and port 4. This particular arm is called E arm. It is same as that of E plane T. जैसे मैंने बताया, it is combination of E and H plane T. So it is called hybrid T. It is a magic T because you can apply power at any one of the ports and you can get the power output from remaining two ports. अब देखो यहाँ पे चार पोर्ट्स है. सपोज आई विल अप्लाई द पावर टू पोर्ट 4 एंड पोर्ट 3, देन power will come out from port 1 and it will be addition of both the powers. In that case, this port 2 should be terminated. The meaning of word termination means you need to connect certain load at this port. जैसे मैंने बताया, ये E arm है. This particular section is H arm, which is same as H plane T. We know that in case of E plane T, if you apply the input power, then at the output side you are getting the power which is 180 degree phase shifted. So if you apply the signal power to port 4, then these two things, port 1 and port 2, these represent side arms. So as I said, this port 4 is corresponding to E arm. So if you apply input power to port 4, then power gets equally divided to the two side arms. That means power gets divided to port 1 and port 2. But as we discussed in the earlier video, in case of E plane T, the power is getting divided, but both the waveforms will be 180 degree phase shifted. That means whenever you will apply input power to the E arm, that is port 4, you are getting output power from port 1 and port 2, but those two waveforms will be phase shifted out of phase. Opposite case, if you apply power to port 3, look at the diagram. Port 3 is corresponding to H arm, that is H plane T. We know that the characteristics of H plane T is that if you apply power at one input port, then you are getting output power from both the ports, but these output powers, output waveforms will not be out of phase, they will be in phase. So if you apply power to port 3, that is H arm, then you are getting output from both ports 1 and port 2, and both these waveforms, output waveforms, will not be out of phase, they will be in phase. That means we can say there will be 0 degree phase shift. Now applications of this magic T. So I have listed out few applications. It can be used as a mixer. That means it can be used to add the power. जैसे मैंने बताया, if you apply power to port 4 and port 3, then addition of power takes place and you may get the power at the output of port 1. In that case, this port 2 should be unused. मतलब ऐसे याद रखना है. If you are using 3 ports out of 4 ports, then the remaining fourth port, which we are not using, should be terminated to the matched load. That means this port should be closed. Now applications are balanced mixer, that is as I mentioned, it can be used to add the powers. Then antenna duplexer circuitry, then measurement of unknown impedance, ये application हम लोग डिटेल में डिस्कस करने वाले हैं. Then impedance bridges, and it can be used as an isolator. Isolator means if you want to isolate two devices, then in that case magic T can be used. This is the S matrix of magic T. याद रखने के लिए बहुत सिंपल है. Since there are 4 ports, so the size of matrix will be 4 rows and 4 columns. That means 4 by 4. This is the first row, so I have written the notations. S we know that it is a scattering parameter. So S12, S1, S11, S12, S13, S14. Second row, S21, S22, S23, S24. Same way, third row and fourth row. So I have written the generalized notation starting from S11 to S44. जैसे मैंने बताया S represents the scattering parameter. So there are 4 ports. So size of this matrix S parameter or S matrix is 4 rows and 4 columns. That is 4 by 4. Now one important concept. There is a concept of symmetry in case of magic tape. What is this symmetry? जैसे ये यहाँ पे एक हम लोग डिवीजन करेंगे. मीन्स इफ आई विल ड्रॉ वन प्लेन एट दिस एंड, लाइक इफ आई विल ड्रॉ द प्लेन लाइक दिस, सपोज ये प्लेन ऐसा ड्रॉ करेंगे, दिस इज द प्लेन, then in that case half portion will be at LHS, remaining half portion will be at the RHS, and both these parts, both these portions will be symmetric. So this is called condition of symmetry. So this particular plane which I have drawn with black ink, this represents the plane of symmetry, means at both sides you are getting equal structure. So this is called plane of symmetry. So the condition of symmetry can be written as S12 is equals to S21. बहुत simple है. S12 means it is related to port 1 and port 2. You can well say like this, from port 1 to port 2, S21 from port 2 to port 1. So as I said, there is a condition of symmetry. That means S12 is same as S21, S13 is same as S31, S14 is same as S41, S23 is same as S32, S24 is same as S42 and S34 is same as S43. तो यहाँ मैंने अंडरलाइन करके रखा है. जैसे देखो ये S12 इसके बदले में ये प्रॉपर्टी देखो, S12 is same as S21, तो ये जो टर्म है S21 इसके बदले में I can write S12. Same way S31 is same as S13, so I will write S13. S41 is same as S14, so here I will write S14. Then S32 is same as S23, so I will write here S23. S42 is same as S24, so I will make changes over here. I will write it as S24. Then S43 is same as S34, so I will write over here S34. So I have changed the contents of this matrix by using the symmetry property. Now, just now we discussed there are two arms, E arm and H arm, because magic T is combination of E and H plane T. Do remember the basic concepts. Whenever you are using E arm or magic T, ET, then in that case the power is getting divided into two side arms and the waveforms are phase shifted by 180 degree. So when power enters from port 3, first we'll discuss about H plane. See, as I mentioned, in case of E plane the power is getting phase shifted. In case of H plane the power input gets divided it into two ports, but there will not be any phase shift. So when power enters from port 3, this is port 3. So if I'm talking about H arm, when power enters from port 3, it gets equally divided into two side arms. That means these two are side arms, port 1 and port 2. And in that case, coupling to port 1 and port 2 is equal. That means there will not be any phase shift. So S13 is same as S23. Make it more simple. S13 it is related to port 1 and 3. S23 related to port 2 and 3. जैसे मैंने बताया पोर्ट 3 को हम लोग पावर अप्लाई करेंगे तो पोर्ट 1 और पोर्ट 2 से आउटपुट पावर आ जाएगा, बट there is no phase shift. So S13 is same as S23. Let us make use of this condition. तो यहाँ पे S13 है, इसके बदले में S23 लिख सकते हैं हम लोग, और मेक इट लाइक रिमेंबर इट लाइक दिस. जैसे यहाँ पे था S21, हम लोगों ने क्या लिखा S12, मतलब ऐसे याद रखना है, नथिंग टेक्निकली, ये सिर्फ याद रखने के लिए. पहला जो सफिक्स है ये लोअर नंबर होना चाहिए. सो सिंस S13 is same as S23, in place of S23 I will write S13. So here I will make the change. I will write S13. What I did in case of S23, I have written S13. Then when power enters from port 4, again the same logic. Port 4 is related to E arm. So when power enters from port 4, port 1 and port 2 are 180 degree phase shifted. We discussed it. So in case of E plane T, when power enters from port 4, port 1 and port 2 are 180-degree phase shift. That means S14 is equals to minus S24. Again, remember it like this. हम लोग power input apply कर रहे हैं port 4 से. Two side arms are there, port 1 and port 2. So power division takes place. But this is the characteristics of E plenty. There will be phase shift of 180 degree. So I have written S14, it is related to port 1 and 4, is equals to minus S24. Why minus? Because there is a phase shift of 180 degree. Same equation can be written as S24 is equals to minus S14. So in case of S24, I will write minus S14. So in case of S24, I have written minus S14. Then port 3 and 4, port 3 and port 4. This port 3 corresponds to H plenty, port 4 corresponds to E plenty. So these are opposite to each other. We know that electric and magnetic fields are 90 degree perpendicular to each other. So port 3 and port 4 corresponds to H and E plane. Therefore, S34, that means there is no connection between 3 and 4 because one is electric and another is magnetic. So S34 is equals to 0. So this S34, I will write it as 0. Similarly, this term is again S34. So it becomes 0. Now let us simplify this matrix. I mean, we will derive the S matrix for the magic T. ये टर्म भी चेंज करना है हमें. S24, just now we discussed S24 is same as minus S14. So this I will write it as minus S14. Now we discussed the concept of symmetry. ये भी याद रखना है आप लोगों को. Due to symmetry, S11 is same as S22. S11 is related to port 1, S22 is related to port 2. These two ports I am talking about. So due to symmetry, S11 is same as S22. So in this case, in place of S22, I can well write it as S11 because S11 is same as S22. Then another important thing, port 4 is related to E arm, that is E plenty. Port 3 is related to H arm, that is H plenty. Always there is a matching of port 3 and 4. That means due to matching of these electric and magnetic related ports, S33 is equals to S44 is equals to 0. So this term S33 becomes 0. Similarly, S44 becomes 0. Now we have got this S matrix. One more thing, this we already discussed. This S23 is same as S13. So let us make the change at this point. So I can well write this as S13. We already discussed this. S23 is same as S13. This is the matrix S. S asterisk, that is complex conjugate of this matrix. It's very simple. Whatever elements are there, I have written complex of each term. In case of complex conjugate, the notation asterisk is used. So this term is S11, corresponding term is S11 asterisk, and so on. Now, do remember the basic property. The matrix S into its complex conjugate, that is S into S asterisk, is equals to 1. Now we will do further calculations. So first of S, that means, see, I have written using some short notations. First रो ऑफ एस, ऐसे याद रख लो. हम लोगों को ये दो मैट्रिक्स का मल्टीप्लीकेशन लेना है, बट कीपिंग इन माइंड एस मैट्रिक्स एस इनटू इट्स कॉम्प्लेक्स कॉन्जुगेट इज इक्वल्स टू 1. तो इसका जो भी हम लेंगे दैट विल बी कंसिडरिंग ओनली रो. दैट मीन्स corresponding row of S will be multiplied with corresponding column of S asterisk. So first of S, that means first row of matrix S, जैसे मैंने बताया याद रखने के लिए ऐसे याद रखना है. इसका जो भी ले लेंगे हम लोग that will be corresponding to row. It will be multiplied with the column of S asterisk. So first row of S into first column of S asterisk. So first row, that means these terms will get multiplied with these terms. So first S11 into S11 asterisk. So if you multiply any term with its complex conjugate, then it becomes magnitude of that term square. So S11 into S11 asterisk is corresponding to mod of S11 square. Then this second term, I am multiplying first row of this matrix with first column of S asterisk. So Second, S12 into S12 asterisk, that becomes mod of S12 square. Same way, third, this is S13 into S13 asterisk, this term. So it becomes mod of S13 square. Fourth, S14 into, I'm talking about this first column, into S14 asterisk is mod of S14 square is equals to 1. Let us say this is equation 1. Now, थर्ड ऑफ एस एस्ट्रिक, जैसे मैंने बताया याद रखने के लिए, ये सिर्फ नथिंग टेक्निकल. थर्ड ऑफ एस एस्ट्रिक मीन्स थर्ड column of S asterisk. So third column means this column, I am talking about this column multiplied with third row of S. This is matrix S. Third row means this row. So I will take multiplication of S13 asterisk into S13. That becomes mod of S13 square. Then second term, this mod of S13 asterisk into mod of S13 asterisk again becomes same mod of S13 square. These are two same terms, so it becomes 2 times mod of S13 square is equals to 1. Therefore, S13 is 1 by root 2 because this is S1 mod of S13 square. So actually it becomes mod of S13 square is equals to 1 half. That means S13 is 1 by root 2. Next, fourth of S, that means fourth row, this row, fourth row of S multiplied with fourth column of S asterisk. That means this fourth column. So S14 into S14 asterisk becomes mod of S14 square. Then minus S14 into minus S14 asterisk again becomes mod of S14 square is equals to 1. So 2 times mod of S14 square is equals to 1. That means S14 is equals to 1 half. Put these values, S13 is equals to 1 by root 2, S14 is equals to 1 by root 2 in equation 1. Therefore, I will get mod of S11 square plus mod of S12 square plus, see, this is mod of S13 square and we have S13 is 1 by root 2. इसका square लेना है, so it becomes 1 half plus mod of S14 square, we have S14 is 1 by root 2, so it is 1 by 2 is equals to 1. This 1 half plus 1 half becomes 1. Therefore, I can write mod of S11 square plus mod of S12 square is equals to 0 because this becomes 1. If I will transfer at the RHS, it becomes 0. Now, keeping in mind the matched condition of port 1 and port 2, we can easily write this as S11 is equals to 0 and S12 is equals to 0. Let us put all these values in this matrix S. So, we discussed S11 and S12 are 0. So, these two terms become 0. Similarly, S12 is 0, S11 is 0. Now, S13 is 1 by root 2. So, here I will write 1 by root 2. S14 is again 1 by root 2. This terms becomes 1 by root 2. S13 1 by root 2. Then this minus sign will be as it is. S14 is 1 by root 2. So, this term is minus 1 by root 2. These are all zeros. Then S13 is 1 by root 2. S14 is 1 by root 2. S13 is 1 by root 2. And minus sign remains as it is. This is again minus 1 by root 2. So this is matrix S for the, derivation of S matrix for the magic T. Now let us discuss one application of a magic T. From the exam point of view, we may expect the question like this: how magic T can be used to measure unknown impedance. This is the block schematic which shows how magic T can be used to measure unknown impedance. This block corresponds to the magic T which we already discussed. This is port 1, port 2, port 3, port 4. At port 3, we have connected one microwave source. At port 1, we have connected known impedance. This is the standard known impedance which can be varied, which can be changed. At port 2, we have connected unknown impedance which we want to measure. And at port 4, we are using null detection. That means the device which shows 0 output. Now, one important thing, we have discussed the S matrix of the magic T. So, basic formula is the output coefficients, output terms, that is B is equals to matrix H, S into matrix A. A represents the input coefficient A1, A2, A3, A4. Let us make use of few notations. P1 indicates reflection coefficient of arm1, P2 indicates reflection coefficient of arm2. What are these reflection coefficients? Look at this diagram. At port 1 and port 2, we have connected known standard impedance, and at port 2 a known impedance which we want to measure. But these two impedances initially are not equal. Since they are unequal, there will be reflection. So P1 represents reflection coefficient of arm1, P2 represents reflection coefficient of arm2. Now P, that means power at port 1. This is the power. Make the thing simple. We are not going to in detailed mathematical analysis. ऐसे याद रखना है. एक रिफ्लेक्शन कोएफिशिएंट होगा और हम लोग पावर मेजर कर रहे हैं. दिस इज पावर एट पोर्ट 1, सो नोटेशन इज P1. इट इज पावर, so 1/√2 times P1 into A3. Why A3? Because we have connected microwave source at port 3. So power at port 1 is P1 A3 upon √2. Same technique, power at port 2 is P2 A3 upon √2. Now see, we have connected microwave source at port 3. There will be division of power at port 1 and port 2, and at the null detector at port 4 we want to combine these two things. Actually there will be subtraction. So again we want to measure the power at null detector, that is power at port 4. So 1/√2 times this value P1 A3 upon √2 minus second value P2 A3 upon √2. This 1/√2 into 1/√2 becomes 1/2. Same technique. This 1/√2 into 1/√2 becomes 1/2. I have taken 1/2 common. So 1/2 inside the bracket P1 A3 minus P2 A3. Again take A3 common. So it becomes 1/2 A3 P1 minus P2 is equals to 0. Now for the null detection, अब देखो क्या करना है, हम लोगों को ये unknown impedance measure करना है. So go on changing this value of known impedance in such a way that at the null detector you will get 0 output. So for the null detection, this term, that means power at port 4 will become 0. So this term becomes 0. तो ये लोग हम ये 1/A3 यहाँ पे RHS में ट्रांसफर करेंगे. So you will get P1 minus P2 is equals to 0. That means P1 is equals to P2. This is the null condition. In terms of impedance, I can write, since P is related to port 1, P1 is related to port 1, Z1 minus Z0 upon Z1 plus Z0. Z is impedance. For port 1, notation is Z1. Z0 is standard characteristics impedance, or you may say output impedance. Then P2 is Z2 minus Z0 upon Z2 plus Z0. Z1 impedance is node impedance, standard impedance. Z0 is also characteristics impedance. So from this equation, if you are getting a null condition, so we can measure the unknown impedance Z2. So dear students, that's it for today's session. So thank you. Thanks a lot for watching this video.